So in this video, we're going to look at how we can use the dot product to help us with some physics problems. The first one, a wagon is pulled horizontally by exerting a force of 20 pounds on the handle at an angle of 30 degrees with the horizontal. We want to know how much work is done with the wagon if it moves 100 feet. How much work is done in moving the wagon 100 feet. So the definition of work is force times distance. So we're going to think about this in terms of a force vector and then a distance vector. I'm going to call it AB. So our force vector, we need to think about that pounds of force being exerted. That's our magnitude. And then the angle. It looks like I misspelled angle here, sorry. Being an angle 30 degrees with the horizontal. So here's our wagon. Here's the handle on the wagon. Right here, this is our 30 degrees that we're talking about. So our force vector is going to be 20 times cosine of 30 degrees, sine of 30 degrees. Cosine of 30 degrees is square root of 3 over 2. Sine of 30 degrees is 1/2. So if I were to multiply through, I'm just going to simplify this as far as I can. I'm going to end up with 10 square root of 3 and 10. So what's my AB vector? Well, my AB vector is how I'm moving. And because I'm just moving in a horizontal direction, I can think about it in terms of an X and a Y coordinate. So there's my vector moving 100 degrees along the horizontal. So find the dot product. So we're going to have 100 times 10 square root of 3 plus 0 times 10. So that's going to be 1,000 square root of 3. And if I were to type that in my calculator to get a decimal approximation, I have 1732.05. Work is in foot pounds. Let's look at one more. We have a Toyota with a gross weight of 5,300 pounds parked on a street with an angle that's on an 8-degree angle. We want to find the magnitude of the force required to keep the Senna from rolling down the hill. And then the force perpendicular to the hill. So this is where we're going to use decomposition. So let's talk about that gravitational force and what's going on. I'm going to draw a quick picture. So this is 8 degrees. Here's my car. So we're on a slight incline here. When we think about that force, this is the force with respect to gravity, and it's always acting perpendicular to the Earth. That's why I'm drawing that as a perpendicular line. And it's always in a downward direction too. So it's going to be negative. Okay, so it's acting perpendicular. Think about it as a vertical component, not a horizontal component. That's why my horizontal was 0. So I need a vector. Now I'm going to use a unit vector along the ramp. So this is going to be, I'll call it vector u. You can think about it as cosine of 8 degrees, sine of 8 degrees. So let's find V1. So it's that gravitational force times vector u, or dotted with vector u, over the magnitude of u squared. times U. So if I were to find that dot product of this guy with this guy, I'm going to have 0 minus 5,300 sine of 8 degrees. We know the magnitude of U is going to be 1, so 1 squared is going to be a 1. So I'm going to turn this into some numeric instead of dealing with sine of 8 times cosine of 8 and so on. So negative 5,300 sine of 8 cosine of 8 is about negative 730.4390. I'm going to use 4 decimal place to ensure some accuracy here. So there's my vector representation. So the force needed to hold it in place. We need to find the magnitude of that. And I'm just going to do that in the calculator. So it's going to be square root of this squared plus this squared. And when I did that, I got about 737, 6174. Okay, so remember, that's the parallel component. That's the component that's along that ramp. Now we want to find the magnitude of the force perpendicular to the hill. That's where we're going to go with V2. V2 is the perpendicular component. So I'm going to take that F and subtract V1. So if I take F and I subtract V1, I'm going to get 730.4390. And then negative 5,300 minus negative 102.6565 is still going to be a negative. So there's my perpendicular component. And if I find the magnitude of that, that will tell me the force perpendicular to the hill. Now I'm going to use this symbol for perpendicular to hill. I'm just going to use my calculator off to the side to compute that. And I got about 5248 for that. Okay, let's look at one more, and this is where you may want to pause the video, try it, come back, check your answer. So Billy and Timmy are using a ramp to load furniture into a truck while rolling a 250-pound piano up the ramp. They discover that truck is too full of other furniture for the piano to fit. Timmy holds the piano in place on the ramp while Billy repositions the other items to make room for it in the truck. If the angle of inclination of the ramp is 20 degrees, how many pounds of force must Timmy exert to hold the piano in position? So this is going to work the same way as the last one. So we've got this piano that's going up this ramp, and the ramp has a 20-degree incline. So here's my piano. We want to know how much force he's going to exert. So we're still thinking about that gravitational force. And that gravitational force acts perpendicular to the Earth. The piano is 250 pounds. That's your gravitational force. Remember, it's acting in the horizontal direction only, And it's always going to be negative because it's coming towards the earth. So now we need to describe that ramp. I'm going to use the unit vector along the ramp. So it's going to be cosine of 20, sine of 20. So what we want to do now is we're going to do a projection. We're going to project that gravitational force onto the ramp. So V1 is going to be that gravitational force dotted with U over the magnitude of U squared times U. So we have negative 250 sine of 20 degrees as my dot product. We know the magnitude of U is 1, so the magnitude squared is 1. Dot it with U. We have negative 250 sine of 20 degrees, cosine 20 degrees, and then my y component is negative 250 sine squared 20 degrees. So the scalar is multiplied to each of those pieces inside of U. Now, I'm going to, again, turn that into numbers. I'm just going to do this in my calculator. It's about negative 80.3485. Negative 29.2444. So there's my V1. And then I need to find the magnitude of that. I'm just going to do that in my calculator. It's the square root of the x component squared plus the y component squared. That'd be about 85.5. So how much force does Timmy exert? He has to exert about 85.5 pounds of force to hold the piano in position. If he exerts more than that, he's going to push that piano up the ramp. If he exerts less, then the piano is going to push him down the ramp.